Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, today we will perform lab number 3. The title of the lab is to study the no-load characteristics of separately excited DC generator. Now this is the whole setup you can see here. We are having the machine. This is the DC machine trainer on which there is this is the machine here, the DC machine, and this machine can be used as a motor and this can be used as a generator. This is the DC machine. Similarly, we are having there is another machine, and that is the motor. This is the induction motor. And this lab, in this experiment, this induction motor will be used as a source of prime mover to rotate the shaft of this DC motor, and as a result voltage will be induced in the armature part of this DC machine. So this is the motor and generator setup. According to the circuit diagram I have shared with you people, we are having this DC supply, positive and negative 220 volts, and that is input to the variable resistor rheostat, and the output of the variable resistor, that is through this ampere meter. This ampere meter is connected in series, and the output of this ampere meter is connected to the E1, to the excitation of this DC machine, the separate excited DC generator. And similarly, the E2 terminal is connected to the negative terminal of the supply. So in this case the excitation is separate. That's why this whole setup is known as the separate excited DC generator. Okay, now I'm switching on the induction motor. So the induction motor has started. This is the induction motor, and here this is the three-phase V1, W1. These are the three-phase induction motor, and the lower end U2, V2, that is are connected together in the star position. So that is the star connected induction motor. The stator is star connected. Okay. So here in this setup, the DC voltage is switched off, and as a result you can see here there is the IF, the excitation current is 0, and there is due to the residual magnetism there is small value of the no load voltage that is generated, that is equal to E0. Now I am switching on the excitation voltage, which is 220 volt. Let me turn it on. Now you can see here that 0.04 ampere current is flowing and the voltage is 230. So what we will do in this experiment, in this lab, we will increase this excitation current by means of this variable rheostat, variable resistor, and as a result the no load generated voltage will also increase. So I'm changing the value. The value of this rheostat is 2200 ohm. So I'm changing the value, and you can see here the value of the current hasn't changed. Now let me decrease the value of the resistance. Now the value of the current has increased from 0.04 to 0.05, and the voltage is 246. Similarly, I'm increasing the voltage. I'm decreasing the resistance. As a result, the current is 0.06 and the voltage is 268 volts DC. Now let me further decrease the resistance, and the current is 0.07 and the voltage is 283. Similarly, I am further reducing the resistance, and the current increases from 0.07 to 0.08 and the voltage is 303 volts. Let me further decrease the value of the resistance, that is in so the current is 0.10 ampere and the voltage increases to 317. So that's it. So in this lab, it's very obvious that we can by decreasing the resistance and the value of the current increases. When the value of the current, excitation current increases, the strength of the magnetic field increases. When the strength of the magnetic field increases, the no load generated voltage will also increases. Thank you.